Now, in this video, we will going to discuss about the problem number 52. A steel rod of 20 mm diameter is enclosed centrally in a hollow copper tube of external diameter 40 and internal diameter is 25 mm. The composite bar is then subjected to an axial pull of 50 kN through a rigid cover plates. If the length of each bar is equal to 200 mm, determine the stress in the rod and tube. Number 2, load carried by each bar. And number 3, elongation of the assembly. So the Young's modulus of steel bar, which is ES, will be equal to 2 into 10 to the power of 5 Newton per mm square. And Young's modulus of copper equals 1 into 10 to the power of 5 Newton per mm square. So now we will consider a copper tube, and inside that we are going to have a steel rod, and this has been covered with the cover plates and we have an axial pull of 50 kN. So how to solve this problem? So first, in the stress in the rod and the tube. So what is the area of the cross section of the steel rod? So the diameter of the steel rod is 20 mm. So pi by 4 into 20 square, it is the area of cross section of the steel rod. So that will be equal to, on simplification, you will going to get it as 314.16. Then area of the copper tube you want. So the pi by 4 into 40 square minus 25 square. So this is the hollow circle. So you will go on simplification, you will going to get it as 765, that is 765.763 mm square. Now the load carried by the steel rod plus the load carried by the copper tube will be equal to the total load or the total applied pull. What is the load carried by the steel rod, which will be equal to PS plus PCU equals P. So you express PS in terms of stress and the area of cross section, because stress is load by area of cross section. So since I want the load, it will be stress into area of cross section. So express PS as sigma S into AS plus sigma CU into ACU will be equal to 50 kilonewton. So convert that into Newton, which will be 50 into 10 to the power of 3. Also we know that what is the either the extension or the compression. Since it is the tensile load which is applied, the extension in the steel rod will be equal to the extension in the copper rod or the copper tube. So therefore, which is delta LS will be equal to delta LC or LCU. So express this, what is delta L, which is P into L by A into EU, A into E. So here, since it is the elongation with respect to steel, so PS into LS by AS into ES will be equal to PCU into LCU divided by ACU into ECU. So what is PS by AS? PS by AS is nothing but sigma S. So sigma S into LS by ES will be equal to sigma CU into LCU by ECU. So substitute the values as length of steel rod and the length of copper rod will be equal. So it will going to be get cancelled. So therefore, substitute the value of ES and ECU. Sigma S by 2 into 10 to the power of 5 will be equal to sigma CU into 1 into sigma CU by 1 into 10 to the power of 5. So on simplification, sigma S will be equal to 2 times sigma CU. Now you substitute this substitute this sigma S in this particular equation, wherein sigma S will be equal to 2 into sigma CU into AS plus sigma CU into ACU is equal to 50 into 10 to the power of 3. You know the value of AS and you know the value of ACU. You substitute that here. 2 sigma CU into AS is 314.16 plus sigma CU into ACU is 765.763 is equal to 15 to 10 to the power of 3. So once you do that, so you will going to get the value of sigma CU, which will be equal to 35.866 Newton per mm square. Once you get the value of sigma CU, so sigma S will be equal to stress induced in the steel copper tube will be equal to sigma CU, which is 35.866 Newton per mm square. Similarly, stress induced in the steel rod is sigma S will be equal to 2 times sigma Cu. So 2 times 35.866, which will be equal to, on simplification, you will going to get it as 71.732. So this is how you will be able to produce, you will be able to calculate the stresses in the both copper tube and the steel rod. Now, what is the load carried by each bar? The load carried by each bar is load on steel will be equal to PS, which is equal to sigma S into AS. So what is sigma S? 71.732 into area of steel bar is 314.16. So once you simplify that, you will going to get it as 22,535.3 Newton, which is equal to 22.535 kilonewton. So similarly, what is the load on the copper tube? The load on the copper tube PCU will be equal to sigma Cu, which is sigma Cu into ACU will be equal to 35.866 into ACU is 765.763. On simplification, you will going to get it as 27,464.8 Newton, which will be equal to 27.5465 kilonewton. So what is the elongation of the assembly? The elongation of the assembly, which is delta L, will be equal to, either you can take delta LS or delta LCU. So as delta LS is equal to delta LCU, so that is equal to PS into LS by AS into ES, which will be equal to PS by AS. You substitute it as sigma S into LS by ES. You know sigma S is 71.732 into 200 by Young's modulus of steel, which is 2 into 10 to the power of 5. On simplification, you will go to get delta L as 0.717. Even if you substitute for delta LCU, you will also get the same value. So this is how you will be able to solve this particular problem. Thank you.